Ever wondered why the hair-thin circuits on your phone's flexible FPC flexible printed circuit don't easily oxidize or short-circuit? The answer lies in FPC printing. It's like adding a custom protective coat with ink to shield key areas, keeping circuits stable. First, pre-printing prep. In a clean room, workers wear anti-static gloves and wipe FPC surfaces along circuit lines with a lint-free cloth dipped in special cleaners. All dust and fingerprints must go. Even tiny impurities can ruin ink adhesion, causing bubbles or peeling. Nearby, techs set up the screen printer. They fit a stencil with hollow patterns matching ink areas and calibrated parameters. Squeegee pressure at 0.5 gg, printing speed at 40-60 mm. Too fast, ink smudges. Too slow, it piles up. Next, the core printing. The FPC is fixed on the printer's workbench. The stencil's flowers to fit the FPC. Then the squeegee glides across. Ink seeps through the stencil's hollow parts, covering circuits evenly. Only solder pads stay exposed. After printing, the FPC goes into a 60-80 C oven for 15-20 minutes to dry the ink into a hard, peel-resistant layer. Then comes inspection. Inspectors use a flashlight to check for missing ink, messy edges, or ink on pads. They also do an adhesion test. Press tape on the ink. Peel it fast. No ink residue means it passes. High-precision FPCs get automatic optical inspection scans. Which spot even 0.1 mm flaws like ink overflow. This simple step is key to FPC durability. The ink coating blocks air and moisture, preventing rust, and shields circuits from scratches during assembly. Curious about other FPC steps or ink types? Share in the comments.